Good afternoon from Vic Gardner. I'm glad that you were all able to join us for our office hours today. Today's topic will be measurement of effect coatings. And as I mentioned, it's an office hours. So we will have a shortened format, a shorter presentation, and then really open it up for any questions that you may have. Please feel free to type them in the chat, and we will get to as many questions as we can, and any that we don't get to, we'll be sure to contact you afterwards. We are recording this presentation, so you will receive a link to the recording after the webinar. And if you have any problems with the sound, I think in the chat there's some information if you needed to dial in on your phone. And I think with that, I can now turn it over to Noah, and he is going to be our presenter today. Although we may have just lost Noah. Oh, no, there he is. I'm having some trouble hearing Noah, so I think he may be coming off and coming back on. Hopefully everybody could hear me. I believe he's in it.
Testing, testing. Can you hear me?
I can hear you now, Noah. So yes, I think we're good.
Awesome. All righty. Yeah, so sorry about that there. Let's go ahead and get started. So today, like we said, we're going over measurement of effect coatings, how that's done. The instrument specifically we'll be going over is the BYK-mac. So let's go into it. So starting off, whenever you have color measurement of any sorts, you want to first have three critical items. You need a light source, and so that can be used as, let's say, the sun, for example. You need an object, and then you need an observer. Obviously, we need an observer because we need somebody to view that color. In the instrument's case, it's your spectrophotometer. In all other cases, it's typically a person that's viewing an object. So when we get into color, I'll show this wonderful slide here. This pretty much goes over what's exactly happening at the level of the surface when we have color. And so essentially we have incident light. In this case, it's the sun. It has all of the colors of the rainbow, so all visible light. And we see first it hits the surface, and our initial reaction there is our specular reflection, or our gloss, and that's reflected at the opposite angle that it comes in at. Our second interaction that also happens simultaneously is our absorption. And so your absorption is happening where all of the colors except the color we see it as is absorbed into the material. This is based off of selective pigments. And as that gets absorbed, you also have a diffused reflection of the color that we see it as. And so when we look at the slide here, we see the surface is orange. It has orange selective pigments in it. And so what we see the final object as is orange. And so that's with your typical opaque sample. But when you start adding special flakes and other categories of effect, then you have some other attributes that occur. So one of them is the absorption pigments. So like I mentioned before, it's selective on specific colors. And so it'll specifically block out and refract certain wavelengths of light while absorbing other wavelengths of light. And our second interaction, or second type of pigment, is metallic pigments. So these are metallic gloss. They have a mirror-like reflection. The light will typically hit that surface and then reflect the opposite direction, usually giving like a mirror look finish. And then lastly, we have our pearl luster pigments. And so again, these are specific color selected pigments, but they have an additional attribute where they have a color flop. And that's just due to how it's refracting the specific wavelengths of light. We'll get into that later on. So let's look at the instrument itself and how it takes these measurements. So internally, this is how the instrument's set up with its different sensors and optical components. You have a lamp that is set up at 45 degrees. Then you have different, let's say, spectrophotometers that measure at these different angles. And the reason we want different angles is because with these metallic surfaces or special pigments that are used, the color changes not just at the 45-degree angle, but now across all angles. And so as we change our viewing angle and look at the sample that we're measuring, we're going to see it will have either a color flop, a light dark flop, or in some cases it might change into a completely different color. And so internally we have sensors at -15 for detecting those pearlescent flops. So when you have a full transition from, let's say, like a blue to a purple or blue to a green, we have 15 degrees, 45 degrees, 25, 75, and 110. And so with that, you can then confidently measure and record values for your color at all of these other angles so that you're able to then match and correlate that to different samples and standards. And so let's see why that's needed. So here we have a spectral reflectance curve of a solid green color. And so the spectral reflectance curve for background is your fingerprint of the color. So every color absorbs and reflects light at certain nanometers. And in that case, we're able to graph that and plot it and get this spectral reflectance curve. Now for a solid green, we expect to see our spike happen in the green region. So roughly between 520 to 540 nanometers of visible light. And when we look at the curve of all of the angles, for a solid color, they should be right on top of each other. Because what that means is that the color does not change depending on the angle, the angle, because it's a solid color. Now if we switch to, let's say, a metallic green, now we see those curves are varying. And the main difference is that a reflectance is going down overall. So we see the orange line there at the top is a pretty bright color in reflectance. And as it goes down, changes angles, we see it goes from a lighter green to a darker green. And so that's telling us there's a light dark flop happening in this pigment. Now, when we look at things like metallic silvers, these are the ones that will have the most extreme cases of differences among these angles. So, for example, when we're looking at the reflectance curve for this metallic silver, we see at our -15-degree angle, we're at a very, very light color. And then as we drop down, it almost goes to a complete black, where there's almost zero reflectance, and it's a straight line across the bottom. Now, the reason that a lot of, let's say, manufacturers use this type of color, and metallic silvers are usually prominent, is because they really pick up the contours. And so if you have this metallic silver, say on a very nice ergonomic car, as you change your viewing angle and as it goes over the contours, you're going to see these light dark flops that often bring those contours out more and make it have a more pleasant look. Now, transitioning over to some other effects, let's talk about sparkle. So the instrument that we're referring to, the BYK-mac eye for our multicolor color measurement, it has the ability to also capture sparkle content. And when we talk about sparkle, we're talking about the micro brightness or these glints and diamond appearances that we see on cars. And for these images to be prevalent, you need to have direct sunlight conditions or some type of direct light source. So you can't necessarily view sparkle under a diffused light source. It has to be a direct light that's over top of the surface, illuminating it. The observation angle is critical in that case as well. And when you get into the data analysis side, you can start to really see where collecting this data is important, because you can determine quickly just from looking at data if you have differences in your product that are mainly different at certain angles for sparkle. Let's say at the 25-degree angle, we typically have a sparkle around 3, just for an example. And then we start to see variations later down the road, and we see that now our sparkle is more prominent at 45 degrees instead of 25 degrees. And that could tell us right away that there's an issue in our process where now we can identify it's the application of the coating on the surface, because we can see that the flake is laying at a certain orientation and giving us a certain effect at 25 degrees, but at 45 degrees, now that we have changing numbers, we can see that the flake isn't laying the same. And so we can directly correlate some of these values that we get to issues in our process or issues in our formulation. So it can be used for a lot of different applications. Now, when we look at sparkle again, we have high sparkle and low sparkle. It's usually generated by the individual effect pigment, like aluminum flakes or mica or acrylics. And the amount of effect pigment also influences it greatly, as well as the size. So we have a couple different things going on. And our goal really is to just be able to not only measure and quantify the color at different angles, but also measure and quantify the sparkle effect that's occurring in the coating as well.
Come in with the terminal, so Western Lines. Flight 2683 is going to start the boarding process at door 120. Once again, if you hold any conference on this flight, please make your way down to door 120. Once again, for Southwest Airlines
If you haven't figured it out already, I'm at the airport, so there's a little bit of background noise.
We're going to begin our boarding process at door 120. 120 for DCA.
All right, continuing on. So in conditions where we don't have direct light source, so let's say it's a cloudy day outside, now we have diffused light. And under diffused light, our sparkle now takes a different appearance. Now it takes more of a graininess look to it. It's not as bright, it's not glinting. It gives more of a coarse salt and pepper look. And so now we not only need to identify how the sparkle is looking under this coating, but also how it looks under diffused lighting if our graininess looks the same. And so this really needs a close observation distance, because you're looking at these micro images, these micro textures, and your observation angle isn't important anymore, because we're just strictly looking at the graininess of it. Potential causes of this: so if you have, let's say, high graininess, it almost looks like the static on a TV. And it's usually caused by flake type or flake size, sometimes the disorientation of the flake that's applied to the coating, or it could be an agglomeration of particles. So typically things that happen with the formulation, but it can also take place with the application as well.
This is a general boarding announcement for Southwest Flight 460.
So color is the integral of the spectral reflectance over the measured area. In other words, color is important, like I mentioned before, because you need to make sure the entire surface matches under different angles. But not only do you need color, you also need these effect measurements. And these effect measurements are again caused by the pigmentation and the flakes that are used. So when we get into that, how does this instrument, or BYK-mac eye, which I mentioned earlier, how does this instrument measure these effects? And so it uses a camera analysis to do the graininess and sparkle measurements, and essentially has a spatial resolution for this special chip that correlates it to the spatial resolution of the human eye. And so essentially it's picking up exactly how our eyes are viewing something, and it takes pictures under these different conditions, one being diffused or cloudy, or cloudy sky, and the other being a direct, or let's say a sunny sky. And when it takes these measurements, it takes them at 15 degrees, 45 degrees, and 75 degrees. And again, what you're looking for there is, how is that flake laying? Or what is the sparkle content, the intensity, or the amount of area it's taking up in the surface at these different angles? And so that's when you can really get into analyzing that data. So let's say, for example, if we see at 15 degrees, we have a sparkle area. So how much of sparkle is taken up that measurement location? Let's say we have a sparkle area of 10. Okay, so it's saying this amount of sparkle is in this product. Now, if we then take a measurement of a different batch, we find that our sparkle area increases or decreases. This is telling us there's a direct correlation to our formulation, because it's saying now our sparkle area is decreasing, which means it could be a different flake that's used. It could be less flake that's used in the formula. It could be a variety of different things, but we can narrow it down between process and formulation and really get a good understanding of what's going on. So here we have our instruments here, our BYK-mac eye, which I mentioned earlier. The MAC stands for multi-angle colorimeter, and then the I stands for innovation. So our newer instruments will have the I behind it, and this measures your color as well as your effect, being the sparkle and the graininess measurement. Now also shown here is the spicospectral effect. This is for visual evaluations for those metallic colors or special effect colors, and where you can essentially do exactly what this instrument does. And it's like a light booth with a rotating table, so you can change it from 110 degrees, 75 degrees, 25, and so on. And that way you can physically see what you're measuring and go back and see how the data correlates to one another. You can look at the sparkle differences between panels, and it creates a nice defined set of defined conditions when you're doing these visual analysis. All right, so a fairly short presentation today. Like I said, essentially just going over multi-angle color measurements, as well as the effects that take place, being your sparkle and your graininess. And with that, we'll open it up to some questions. Now, hand it over back to Sherry.
Yeah, thank you. Thank you so much, Noah. And if anybody has any questions, please feel free to type them in the chat. While we're waiting for maybe a question or two. As Noah mentioned, he is at the airport. So we apologize for that little bit of background noise, but that also shows Noah was actually traveling with one of our sales members today. So he does travel out into the field to visit customers if there's, some extra help needed on an application. He gets to share his knowledge and, bring some solutions to the team to help customers, solve their problems.
Yeah, absolutely. And in fact, this trip here was basically going into a manufacturing site and really looking at how can these instruments be used for, like I mentioned earlier, the data analysis portion, as well as how to start collecting the data. So we helped this company develop a set of test methods that they can use and standard operating procedures to go through and then utilize that in their manufacturing. That way, all of their plants are on the same level as far as their quality control goes.
And avoid transporting items without their knowledge.
And it looks like we do have a question. What is the best instrument for measuring silver metallics? And is the output still some kind of LAB reading?
Yeah, great question. So the best instrument for silver metallics is this one here, the BYK-mac, like I mentioned. And the reason for that is because it can measure the color flopping attributes of that specific type of color, as well as the sparkle and the graininess. So you get the full story of what's happening with the color in regards to the multi-angle measurements. And then, like I said, the sparkle that also plays a role in metallic fake, that play a role in that silver color. And the output is still going to be in LAB values, but in addition, you'll have your SA, which is your sparkle area, and your SI values at different angles, which is your sparkle intensity. So you get your LAB data and then your sparkle and graininess data.
And thinking about the BYK-mac eye family, Noah, just to maybe be a little bit more specific, I know we have a Pro, the regular BYK-mac eye, and then the BYK-mac Color. There's also robotics, but for the three handheld instruments, obviously there's a difference between the three?
Yeah, so the BYK-mac Color, that one strictly measures just color. So if you have, let's say, solid colors that you're noticing some traveling, which is starting to become more common, especially as we're able to mill down particle sizes smaller and smaller, you start to get a travel in solid colors, which is something we haven't seen before, at least in recent history. And also in cases where you don't necessarily need to measure your sparkle and effect qualities of the coating. So that would be good for just color measurement. We have the BYK-mac eye, which does the sparkle and the color analysis. I would say that's probably your best bet for measuring silvers, and because you have not only your color that changes greatly for silvers, but also your effect measurements, which can be helpful, especially for characterization. The Pro model that we offer has a special software that goes with it, and that one is made specifically for flake characterization. So if you want to really identify it, and it's used a lot in, say, R&D processes, where you want to go through and really identify what's going on with your flake, how you can optimize it, and different things that you can learn more about. I would say the Pro is probably the best in that case.
Great. Thank you for that explanation. We have another question. How does the thickness of the clear coat affect the sparkle data? And how do the multi-layers of clear coat affect the sparkle data?
Yeah, it's a good question. So the thickness of the clear coat doesn't necessarily affect the sparkle data. And the reason being it's a special camera that senses specifically for that sparkle-like appearance. And in the measurement zone, your clear coat doesn't really play an effect on it, because in the end of the day, for color, we're trying to get our end appearance. So it's going to take into account the clear coat for the color, as in the gloss will affect the color. But as far as the sparkle data, it's not going to have an effect on the sparkle. I see the other question, how do multiple layers affect the sparkle data? Just answered that one. It doesn't play a role into the sparkle data.
Great. There's another question. Can the BYK read exposed carbon fiber UV red clear coat materials?
That is a good question. I'm not sure if I've ever seen or heard of a material like that. But I will say we do offer a service. This goes for all of our instruments, really, where you can send, let's say, a sample of your material in. And then we can take it and go through our instruments and see if we're able to measure exactly what we're seeing. So in the case if it's a exposed carbon fiber UV red clear coat material, you can send in a piece of that sample, and then we can go through and see if we can get the instrument to measure it under different conditions and see what kind of data we can get, and make sure that data is repeatable as well. So that's a service we offer. don't know off the top of my head if it can, just because I've never seen that material before, but it's certainly something we can put to the test.
I hope that answers your question, and you can always feel free to any of the emails that we send, or even Noah can maybe flash back to the last screen. His email is on there. If you reply to any of our marketing emails, those emails come to me, and I will get you in touch with the best person to be able to answer any of your questions, or how we would set up sending in your samples and making sure Noah gets them to process them through the system and help you find a solution. Yep. Good questions. Is there anybody else that may have a question today? Oh, no, thank you. Thank you, Patrick. Well, we're waiting if anybody has any other questions. I will say that on June 11th, Wednesday, June 11th, we have our next office hours, which is color measurement tools and uses. So you're always welcome to join us for as many office hours or webinars as you like. You should have, when you got this invitation, that one should have been listed in there next, and you can, sign up. I wish there was an easy way for you to select them all and register for them all at once, but we haven't come up with that solution yet. So right now you have to kind of click them individually and register for them. Maybe in the future we'll have that option, because I know even for myself, when I register for them, I have to do them all individually as well. So. Any other questions today? Or are we going to give you back a little bit of your hour to maybe have a late lunch or do some more work for this afternoon? I think someone is typing. Noah, do you have any additional comments that you might want to share? Flights are going to be on time and everything. And
yeah, I think I'm going to make it okay. I think I'll grab me a snack and wait out for my plane to take off. But I'll say, if anybody ever has any questions about how to run something or just theoretical questions, feel free to send me an email. The email's on the screen there, and just reach out to us. This is what we specialize in for anything color and appearance wise. And if you have anything that comes up or any questions, we're the ones that can answer them.
With that, I think maybe we'll wrap up for today. And as I mentioned, thank you for joining us and taking time out of your day. We always are excited to have you and get all your great questions. Thank you so much. Have a good day.